I request you all to put your phones on silent mode, please. I am Srishti Tiwari, and it gives me immense pleasure to welcome you all on behalf of my department to the 8th late Professor W.B. Achwal Endowment Oration for the year 2024, organized by the Department of Fibers and Textile Processing Technology, ICT Mumbai. Before starting this intellectual session for today, let's invoke the deity of knowledge for her blessings. Saraswati Namastubhyam Varde Kamarupini Vishwarupe Vishalakshi Vidyam Dehi Saraswati. I thus invite our honorable dignitaries to kindly come upon the dais to light the lamp and request our HOD, Professor Ravindra Kale, to escort them. Acting Vice Chancellor and Dean HR, ICT Mumbai, Professor R.V. Adivarekar, daughter and son of Professor Achwal, Professor Deepti Devbakar and Mr. Abhijit Achwal. Speaker for the day, Professor Ashwini K. Agrawal, Dean Student Affairs, Professor A.R. Atle, and our HOD, Professor Ravindra Kale. Om Asto Ma Sadgamaya, Tamso Ma Jyotirgamaya, Mrityor Ma Amritangamaya. I request all the dignitaries to kindly take their seats on the dais, please. Thank you, sir and ma'am. We shall now have our Institute Geet, Vidyapeeth Geet, Shri Rasayan Devi ke.
Jai
I would request Professor R.V. Adverikar to express our heartily welcome to the speaker of today, Professor Ashwini K. Agrawal, with a sapling. Thank you, sir. I would request Dr. Kedar Kulkarni to welcome Dr. Deepti Devbarkar with a sapling. Thank you, sir. I would request Dr. Kedar Kulkarni to also welcome Mr. Abhijit Achwal with a sapling. Thank you, sir. I now request Dr. Saptashi Maiti to welcome Professor R.V. Adverikar with a sapling. Thank you, sir. I would also like to invite Dr. Saptashi Maiti to welcome the HOD, Professor Ravindra Kale, with a sapling. Now, to commence the program, I would like to invite Professor Ravindra Kale, our HOD, to formally welcome today's August gathering.
Good evening to one and all present. Honorable In-Charge Vice Chancellor, our very own Professor Adverikar sir, today's speaker Professor Ashwini Agrawal, Chair Professor from IIT-Delhi, family members of Achwal family, ICT faculty, students and all the participants, I welcome you all for the today's 8th oration in the memory of Professor W.B. Achwal. I will give you brief information about the person under whose honor we are organizing this lecture. Professor Vaman Achwal earned his BSc Tech in Textile Chemistry in 1953 from the then UDCT. He was a first rank holder. He held 2 PhD degrees, one from Mumbai University in 1957 and second PhD in Aachen, West Germany in 1960. He returned to India and joined the UDCT as a faculty. He was professor of fiber science and also he headed the department for few years. He retired in 1990 and continued to be active as a consultant to the industry. Professor Achwal was a scholar and teacher. He had devoted his whole life to the teaching and well-being of the textile department. He used to teach both at UG as well as PG levels, not only in ICT but in other institutes in India and abroad as well. He guided more than 20 PhD students and about 60 master's students. He published more than 120 research papers in national and international journals. His research in areas such as cellulose modification, solvents for cellulose, physicochemical studies in processing, staining techniques and many other aspects of fiber science has been immensely useful to industries in India and abroad, especially in Germany and Russia. He had been a consultant to many industries within India and Germany. He visited Germany more than 10 times under different study programs and fellowships. He had a good command over German as well as Russian languages. His excellence in the field of textile chemistry was recognized nationally and internationally as he successfully completed projects for Sweden and German governments. He was a member of expert committee appointed by Ministry of Textile to recommend measures to tackle the ban on azo dyes and was expert evaluator for several eco audits. Apart from technical studies, Professor Achwal took keen interest in Marathi literature, drama, music and sports. He was a member of committee to prepare chemistry dictionary in Marathi. He was also involved in the preparation of encyclopedia of textile industry in Marathi. Professor Achwal had received the prestigious UDCT Distinguished Alumnus Award from his alma mater, that is ICT only, and also Hariom Ashram Award in 1987. To commemorate him, his children donated rupees 20 lakhs, and that is how this endowment came into existence. So once again I welcome you all for today's insightful lecture from Professor of IIT. Thank you all.
Thank you, sir. I would like to invite Professor Deepti Devbakar to say a few words about her father, Professor Achwal.
Good afternoon. Thank you very much. And it's a privilege and honor to be here amidst you and in the memory of my father, late Professor Vaman Bhaskar Achwal. Let me first acknowledge Dr. Adivrekar, who is the Dean and also Acting Vice Chancellor, Dr. Kare, Dr. Ashwini Agrawal, today's chief guest, my family and all of you. Many of you are also part of our family and friends, colleagues and students. Professor Kare has already mentioned a few things about my father, but I'll try to reminisce and recollect a few of my memories and few things about him. Sorry. Professor Vaman Bhaskar Achwal was generally amongst his friends and family was known as Pandit. And he acquired this name Pandit because of his sharp intellect, and it is said that, and I have also heard, that he used to be able to solve problems and mathematical sums which senior friends of his or others could not easily solve. And therefore, right in his childhood, he was nicknamed or called as Pandit. After his tenure in UD actually which became his second home, and I'm not just saying it lightly, for him ICT now and UD at that time was a place where he taught, he nurtured students, he mentored colleagues and associates. His students went on to take up very, very prominent positions in the industry and academia. And I should also mention that always he had very, very close relationship with most of his students, in fact all his students, like a family. So we also know many of them very well, is what I just wanted to share with you. After his PhD in ICT, he was amongst the early DARD or German Academic Exchange Fellows, and he got an opportunity to work in Germany, and his work then he earned him a PhD, as was mentioned. But I would like to mention one thing. He was quite impressed by the new order that was coming up in Europe and the way the world was changing. And he insisted and he made sure that he took my mother there, Manik her name was, and she also worked in the industry there actually. And both of them in their lives tried to combine what they thought to them was the best of the Eastern and the Western philosophy at that time point, which impressed us a lot and left a very lasting impression in our family. I should also mention that he was an ardent sports person in addition to his honesty, brilliance, and commitment to work and ability to put in hard work. And really, he could study well. I have seen him work for something. But he was very, very what should I say, I would call brilliant in some sense. And it was very difficult for me to sit and study anything with him because you would expect such high performance, I'm just sharing something very personal, but just to tell you. But he had a lot of patience also at the same time. So if he later on got UNESCO fellowship and also visited America. He spent quite some time in Russia, and as was mentioned, he became very fluent in Russian in writing and reading. He was also, a very fond, ardent person who would like hiking. He, in fact, helped formulate Giri Vihar, a hiking club in Mumbai, and he worked with them for many years. He was also, as long as I remember, he used to continue to play tennis every day in the morning. He would go cycling and he would play tennis. So he was a, sports person in that sense. His, he made large number of friends and very close associates in UD, and many of them remained his friend for his entire life, and they were very, very close again. Uh, Professor Achwal, I remember my father, was very fond of his grandchildren. And, you know, to us, he was very strict, disciplined, and of course affectionate. But to his grandchildren, he used to really dote on them. Is another feature that I would like to mention because I'm telling a few personal aspects. I am aware that he made very significant contributions in many practical aspects of fiber science, textile chemistry. He was also advisor for jute-related aspects to the government of India. And he believed in actually translating the research into practical hands-on things. And really, all through his work, he insisted in developing simple, easy to use, but with large applications kind of technologies. And that is how he, as was mentioned, he helped a large number of industries and companies and also, I mean, his students. Uh, I think I would kind of stop here, and I would say that it is a privilege for me once again and our family. I'm speaking now on behalf of my brother Abhijit Achwal, my sister Swati Achwal, and the entire family, that we were very privileged and honored when ICT actually agreed to institute this endowment. And because for my father, UDCT was part of his life, we are indeed very happy that this is continuing. And, you know, it's a very memorable occasion for us, this endowment lecture. And they have also ensured that we have Galaxio speakers over the years. And today we have Professor Agrawal, whom we are going to listen to in a little while. So once again, I thank you. Actually, I have many things to share with you, but I think I'll stop now for want of time. And I'll just say once again, thank you very much.
I'm sorry to interject, but since it's a family function almost, I will introduce the speaker who just spoke. And although she's Professor Achwal's daughter, in her own right, she's an accomplished person. She did her PhD from Indian Institute of Science, Bangalore. And she was, until recently, the head of Department of Zoology and Biotechnology. Her husband, Professor Dilip Devbakar, was the Vice Chancellor of Goa University. Just thought of mentioning that. And Abhijit is their son.
Thank you, sir, for interjecting and sharing it with us, because now we know that what the legacy is being carried forward from there. Thank you, ma'am. I would now like to invite Shri Arun Narkarji to say a few words about Professor Achwal. Mr. Narkar completed his BSc Tech in Textiles in 1969 and then joined under Professor Achwal's guidance for his master's research and completed his MSc Tech in Textiles in 1971. Since then, he has held various positions in different dyeing and auxiliary manufacturing companies, including a tenure of 20 years at Colortex Private Limited as regional sales manager. He has a total of 38 years of experience in industry. He has also been associated with Textile Association of India, Mumbai unit for 20 years now. I welcome you, sir, to share your experiences. Please.
Good evening. Respected Honorable Vice Chairman, respected Vice Chancellor, Professor Kale, Dr. Adivrekar, Dipti Digbavkar, I think we know her as Chaya, and Abhijit Achwal, my colleagues and friends and ICT students. I am running 80th year of my age, and this is the time to open my memory book and see who influences more in my life. During my 21 years of educational life, my parents, teachers in school, colleges, and institutions are more influential to my life. I remember few names of the schools, colleges, teachers, but their influence confined to the number of years of their teaching. The teacher-students relationship bond is built on foundation of trust, respect, and understanding. Today, in gratitude, in here to express the importance of the enduring bond, this bond should be enriched for lifetime. I remember late Professor W. Achwal for creating strong bond with his students, which inspired me till today. After my BSc Tech degree in textile chemistry, I decided to do the MSc Tech degree, which is partly by papers and partly by research. I approached Professor W. Achwal as guide for my research work. He immediately accepted and asked me to survey on estimation of optical brightening agents applied on cotton fabric using cadogzine solvent. As you know, the cadogzine solvent is the favorite subject of Professor Achwal, and my research based on that. So my research paper was published in Textile Field German Journal in German language. This one of the pride moments, and I feel grateful to learn the significant lesson of life under his guidance. Success is inevitable with consistent, focused determination coupled with hard work. Professor Agrawal inspired us to arrange get-together of his own past and present students, and we approached all his past students and arranged get-together with families. Get-together was arranged every year, and this became platform for discussion and celebrating birthdays, promotions, and sir used to attend students' marriage receptions with family. In my case, he attended not only my marriage reception, but my son's reception also. Yearly get-together was continued till last. I was part of organizers of these events. When I published list of Achwal's research students in 2005, it was 68 research students in that list, which include 9 PhDs. I think this number may be whatever Professor Kare informed. The total number must be okay, and this is as per my list in 2005. It includes 9 PhD and mostly rest, mostly in MSc Techs. Professor Achwal's association remains for 35 to 40 years. And some of his successful research students, which I named, as I know, is Mr. A.B. Gupta, then Dr. R.B. Chavan, Mr. P.V. Bankar, Dr. Sanjeev Kamath, Mr. Subhash Saudagar, Dr. Vijay Abbu, Dr. Prashant Abhankar, and I think I heard recently about Girish Satarkar. These lasting connections foster an environment where learning transcends the confines of textbooks, creating a foundation of their lifelong intellectual growth. Thanks to Chaya and Abhijit for organizing memorial orations of late Professor Achwal every year on his birth anniversary. Late Professor Achwal was fluent in German, as mentioned by Professor Kare. I remember he translated number of letters for me written in Germany. I used to receive from Professor Muller from Germany. And as most of the literature is in German, he was published a series of glimpses from German literature in English in Coleridge. Late Mrs. Achwal, which actually I know the family since long, and I was also appreciating late Mrs. Achwal. She was having hobby of growing bonsai plants during his retired life, and she was awarded many times in most of the exhibitions. I think this is the lesson we have to prepare for our retired life with some hobby. I express my gratitude to late Professor Achwal and his family for their positive influences on our living, and today is the time to acknowledge and celebrate the everlasting commitments coupled with these educational alliances as they contribute to the fabric of blissful life and leave an indelible marks in our memories. Thank you.
Thank you, sir. I would like to invite our acting Vice Chancellor, Professor R.V. Adivirekar, to deliver the welcome address.
Thank you. Let me extend my warm welcome to Professor Ashwini Agrawal. Every time he used to greet me, first time he is visiting Mumbai and I am getting this opportunity, fortunately, to welcome him. Professor Dipti Devbakkar, Abhijit, Dr. Habbu, Professor Kale, all my colleagues, dignitaries in the auditorium. If I start taking name, almost I have to take many names, and then if I forget someone, then that would be difficult. So thank you very much for, as per every year, this is sort of a family gathering for all of us. It's difficult being Vice Chancellor as well as like in his shoes, acting Vice Chancellor. So I have to keep my balance talking about ICT also, but from heart I am textile fraternity, textile family. So I am really very happy to welcome you all. Now about Professor Achwal, about speaking about him would be like ते सूर्याला दिवा दाखवण्यासारखं आहे त्यामुळे मी ते धाडस करणार नाही बट देर आर फ्यू इन्सिडन्सेस विथ प्रोफेसर आचवल विच हॅव रिअली कम व्हेरी हँडी वेन आय हॅव taken up as teaching as my profession. So I recall that our first lecture, and that too was from head of the department. So you have to attend, and being roll number one, I always like, when I used to attend lecture, then first lecture I always used to sit on the first bench. And I still recall that sentence. See, in that time, there wasn't like lectures organized by the department or 7 days that induction program or something like that. You have chosen your profession, you are there in the lecture. So on the very first day, he used to teach us the fiber science. And his first lecture, he said, till the babies are born naked, you don't have to worry. There is a scope to textiles. Now, sometimes we worry that now with this biotechnological development, sometimes जसे कर्णाला कवच कुंडलं होती किंवा अश्वत्थामाला मणी होता तसं एखाद वेळेस कपडे घालून मुलं जन्माला येतील. But that day is still okay. And my another incident was like I was his project student for BSc Tech. And he had given me 4 finishing agents, and as usual I had worked with them, and when I went to show him result, he said, see, in a group, in lots, results are okay, acceptable, but the only thing is, for this sample number, this should be the result, and this sample number, this should be the result. And then probably I was very confident I have done nicely, then I realized that is my mistake. And finally, I was very happy that one thing which I really learned that I would like to say, when I came to MSc Tech, my regularity in the lecture was very bad. So one day he called me and saying, yeah, you are roll number 1, Adivirekar. तुम्ही मला सांगाल का की तुम्हाला कुठला कन्व्हिनियंट डे आणि टाइम स्लॉट असेल ज्यावेळेला तुम्ही लेक्चरला बसाल. And it was like without him saying anything, I started attending regularly. So sometimes nowadays when we enter the classroom, most of the times we find there are only 3 or 4 or 10 students, and then you have to keep on waiting. So sometimes I ask them, की ज्यावेळेला तुला जमेल सगळेजण आल्यावर मला बोलवायला या, मी माझ्या केबिनमध्ये आहे. So that is what, so with all these incidences we have really learned. Now let me come to about ICT. ICT, your own institute is doing wonderfully well. Recently we have backed one project, which is a Sati project, is about 130 crores to develop the facilities for biopharmaceuticals. It is in collaboration with Khalsa College, IIT Bombay, and BRC. Another is like in a polymers, you must have seen that already a center of excellence is operational now, which is sponsored by Praj Industries for the application of biopolymers. Another 2 center of excellence are coming up in polymer department, one for coating sponsored by Pidilite and Asian Paints, and another would be by Pidilite. I thought Professor Kale would say something about the department, but under his leadership, department is also wonderfully doing well. Recently, we have received a grant of about 3 crores for developing the facilities for technical textile, followed by it about 15 days ago, another project which was about 2.7 crores from NTTM to work onto the firefighters' uniform. And very challenging task that without using aramids, we have promised that we will be able to deliver firefighters' uniform. And rather chosen substrate is cotton. I know it's a challenging work, but your department has accepted that challenge, and we will deliver. Another very, I don't know, but it's really, we take pride in saying that. Recently, Dr. Kedar is doing work for Lord Jagannath Puri. They are using silk fabric, something about 180 meters per day is required. And they have converted, see, it is made of a silk. So, needless to mention, it is filament. Right, now they have developed a brand called Karuna brand, where the worm is allowed to come out. So obviously filament is converted into staple, and staple yarn would not have that brightness. So first part of the project we have already completed that with a selected acid dyes itself, we have matched the brightness of it. And next challenge is that we have to do all shade matching into natural dyes. So it's a big challenge, but we are fortunate that we are getting to work for the Jagannath Puri, and already in there that Karuna brand, already many renowned temples in like Tirupati and ISKCON and all those are in a chain. Hopefully in another 6 months we will be able to complete that assignment. So lot many projects are coming, and department is but with all these equipments which are coming, department is also facing a challenge to house them. And I must thank Archroma. They have promised to renovate some of the laboratories in the department through their corporate social responsibility. So my earnest appeal to all of you that if you have anything like that, please approach Professor Kale. He would be there. Another one of the very important development, which is from ICT side as well as from textile sides, because I am also now about 2.5 decades old in this department, and as everybody knows, for many decades, this department was running with 3 or 4 faculties. Right now we have in a department about 7 permanent faculties, and today itself the advertisement has appeared wherein another 7 faculties will be, I don't know how many we will get, but at least we will be in 2-digit number. So that really gives us a strength now to really go out and work for the department. We 4 are there. Dr. Kedar Kulkarni, Dr. Achwal, Kale, and myself. So you must be wondering where are the 3 other faculties. They are not sleeping at home. One of them has taken final year students to factory visit, and 2 of us are setting up our stall in what is Bharat Techs. So with that, again with my earnest appeal to all of you, that it is your department. We are always available whenever you approach. So come and see us. So this is in this family gathering which we have got this opportunity because of our Professor Achwal. And again, I thank you, Professor Achwal's family, for really being with us and helping us in organizing it and making this event very regular. So thank you everyone, and again warm welcome.
Thanks a lot, sir, for sharing all this incidences with us and as well as where the ICT department is headed. I would now like to request our Dean Student Affairs, Professor A.R. Atle, to introduce our speaker for the evening, Professor Ashwini K. Agrawal. Please, sir.
Namaste, good evening, and welcome to this 8th late Professor Vaman Achwal Endowment Oration. And the speaker is eminent scientist and academician, Professor Ashwini Agrawal. Those of you who are from the academic background, I'm sure they would know his name because you must have read many of his research publications. In brief, I will introduce him. He is chair professor of Smart Textiles at the Department of Textiles and Fiber Engineering at IIT-Delhi. He graduated from IIT-Delhi in 1986 and with Institute Silver Medal, and completed his Masters and PhD in Chemical Engineering from the University of Rochester, New York in 1992. He served as Associate Dean R&D and Head of the Central Research Facility at IIT Delhi and Head of the Department of Textiles and Fiber Engineering at IIT Delhi. He has published over 116 research papers in international journals and over 260 papers at national and international conferences. He holds several medals and international patents and has facilitated the transfer of several homegrown technologies from lab scale to the industry level. He is the recipient of several prestigious awards. It's a long list, but the noteworthy of the awards among them are National Award 216 for commercialization of indigenous technology by Technology Development Board, then National Award 2017 for most promising technology for a startup company by Technology Development Board, then Abdul Kalam Technology Innovation National Fellowship by Indian National Academy of Engineering, then Institute Chair Professor and Professor K.L. Chopra Faculty Research Award 2019 for Applied Research, and recently he won another award, Innovation Award 2022, instituted by Foundation of Innovation and Technology Transfer, IIT Delhi. So please join us in welcoming Professor Ashwini Agrawal for today's oration.
Thank you, sir. I now request our speaker, Professor Ashwini K. Agrawal, to take over the dais for the lecture and request the dignitaries on the dais to occupy seats in the front row of the auditorium, please. Please, sir.
Thank you very much. It's a very privilege, it's a big privilege. It's a very special occasion, as I was saying, to be invited for late Professor Achwal's endowment oration. Being shortlisted or selected for such a big thing is something very special to me. After listening to what Professor Achwal has done in his lifetime, I don't feel deserving to be here and speaking in his memory, but I think it puts me in a spot to perform better in my life and to achieve more for the society. I would first like to thank Professor Anirudh Pandit, the Vice Chancellor of ICT, for inviting me for this fellowship. Professor Ravindra Adivarkar, Professor Ravindra Kale, for encouraging me to come here and giving such a wonderful invitation. The family members of Professor Achwal's family, Dr. Deepti Deobarkar And Mr. Abhijit Achwal, I think in memory of your father, you're doing something which is the benefit of the society. It shows how the children, they remember and really cherish the memories of their father. It's very heartening to see that. It's very unusual to see something like this happening today, but it's really says a lot about you and your family. The esteemed members, the guests from industry, the students. I don't know how you will like my lecture. I've never given such a important lecture. While the material in that you may all know already, but I have tuned my talk in a manner that initial few slides I will talk about my lab a little bit, from where I come. And then the rest of the lecture is more tuned to the students. I think there are many students here. On nanotechnology as to how to think about it, and then how you may achieve few things. It's not the entire summary of what is going in nanotechnology. It can't be. In 50 minutes, that cannot happen. But whatever is my experience, I will share that with you. So let's start, and you may stop me in between if you don't follow something, but I'm sure there's nothing rocket science here which I'm going to talk, but something which I have learned with time. So Smita Research Lab is what got established in year 2017. 2007, when we got some funding from DST, from industry and DST together. And we established a center of research in smart materials and innovative textile applications. That is what SMITA stands for. Then we worked very hard to make this lab a state-of-the-art facility where students can get all the facilities under one roof, which is very difficult at the time. And because of these facilities and a very good team of students which we had over the years, we could file various patents and commercialize some of them. And we could win a couple of recognitions because of those commercializations. So we had a long list of companies and institutions with whom we work. Nothing can be done alone. You understand that. It's a teamwork in the end. And obviously money is required everywhere, right? So yes, we had very good support from various ministries and industry partners. These are some glimpses of my lab, Smita Research Lab, which is now declared as Center of Excellence in Smart Textiles by IIT-Delhi. And this is the address where you can go and find more about this lab. This is my research group. Our research areas are wearable electronic textiles, which is an upcoming emerging area. Nanomaterials and textiles, which I will talk about today. The area about nanomaterials. Atmospheric pressure glow plasma. Raghav, I think, is here, one of my students who has worked on this. And specialty materials and yarns and fibers. So we are going to talk more about nanomaterials. So the question comes, why nanotechnology in textiles? Why is it important? Nanotechnology is not something which originated with textile. It originated in the labs of physics and chemistry. Why is it important to us? So well, just to tell you that Indian economy is poised to grow, hopefully to, actually this is to 7 trillion by 2030. And textile is going to be a big contributor. You believe or not, textile industry is huge. And with technical textile as being targeted, this industry is going to contribute to the growth of our country. If you look at the smart textiles globally, so about 2.3 billion 2021, it is poised to grow to 6.6 billion by 26, which is a very good growth rate of 23%. And the driving forces are not going to be traditional textiles only. It's going to be technical textile, functional textiles, and smart and intelligent textiles. Now, these are the words which are overlapping actually. You can't segregate them completely. If we talk about smart textile, it's an umbrella. Okay, and you can call anything tech smart or anything traditional, but what I decide smart and traditional is something which gives you more than a simple protection to your body, becomes a smarter material. But let me first start something which I really love to talk to students about. They have been studying textiles for such a long time. What is textile? Now, unless until we can appreciate what textile is, we will never be able to put our hearts in it. Unless until we know what the importance of textile material is, we will never work for it. We'll always feel we have taken a field which is dying or not so progressive, not paying us so much good jobs and etc. But actually, it is a very wonderful material. So we all know the basic functional material of textile is a fiber or a filament, right? That's a basic unit. It's a one-dimensional structural unit. So this is a cotton micrograph. And when we put this together in some engineered fashion, it becomes either a 1D or a 2D or a 3D material, which we all know like fabrics or 3D fabrics and structures, different structures. And they become highly flexible and load-bearing structures. That is the beauty of when we talk about textile. So how is it unique? What makes it unique? Well, this is a comparison chart of some of the important structural materials or engineering materials which are used today. You can talk about metals, you can talk about civil materials. So if you look at metals, they all have very high modulus. Modulus means stiffness, the bending, twisting. And they have very high strength, very good combination of both. If you look at civil materials, they have very good modulus. They also have good compressive strength, but not really the other strengths. When we talk about tensile, torsional, bending, they are very low. So all these buildings, because of the compressive strength, they are built using civil materials like concrete and things like that. But if you look at textile material, it has a different combination. It has a very high strength, except for maybe compression, not that high, but all of the other things are very high. But modulus are very low. All moduli are low. That makes them very soft, supple, very good to your body, touch to your skin, but they have very, very high strength. This combination of properties you do not get in any other material, engineering material, whatever you see. Even plastics, which you can say polymers make plastic also and textiles also, but they are very, very different because the morphology of polymers in textile fiber is very different from what is there in the plastic sheets on molds and things like that, so make them very different. If you have an application which can utilize this combination of properties, you cannot have anything else replacing it. And that is why human body has chosen this material to be put on themselves. You would not put anything else on your body. So it's a very tough demand which your body makes, which has been fulfilled by textile fibers. That is why this is probably the first kind of materials which humans invented and used on their body from very long time, and we call it traditional. It is traditional, but it is very advanced in ways. If you look at the strength comparison, a plastic will have a strength of 20 to 50 megapascal, a cast iron 200 megapascal, structural steel much higher, 400 megapascal, piano wire, which is the hardest, which is the strongest metal wire you can create, is about 2500 megapascals. But textile fibers naturally are in that range, higher than your metals and plastics. So if you talk about PE gel fibers, textile fibers, they are far exceeding. So they are the best and the strongest material known for applications of technical materials and applications of technical nature, which you do not get in any other material so easily. So let me summarize. I can talk about textile materials a lot actually, but just to summarize some of the important properties. So we know fiber is a fundamental unit of textile. We just talked about it. We also know it's a one-dimensional material. Not many materials are in one dimension. Principally one-dimensional. That means we are talking about properties in one dimension. The other two dimensions are not important. It's not that they're not there, but we talk about principally the properties in one dimension. They're flexible and strong. I just showed you the properties of modulus and strength. But one of the very, very important property, because of the morphology of polymers inside a fiber, is its recoverability. You extend the material and it recovers. You extend it 20%, it recovers 90-95% of it. Which material do you think can do that? Materials in general cannot even extend more than 1% to 2%, they will break after that. This material you can extend by 40%. Wool goes by 40%, right? 40 to 50%. 20-30 is very normal, and you can recover most of it. So this kind of recovery from large strains puts this material absolutely in a different category of materials, which is not possible in anything else. Then comes the applications. When we talk about future, where does textile fit in our future? One of the very important aspects is the cost savings. Why? Because it improves on the life of our roads and highways and and railway tracks and things like that. Because it makes them much better in soil erosion and things like that. It's a saving for energy. Why? Because it's light but strong. So a lot of mobility we are talking about, e-mobility and other mobilities and things like that, they're going to find textile as the material of choice. This can be used for energy harvesting and sensing. Again, an area which is fast emerging internationally. And you must be aware of that, that textile is the material of choice for all that. And then when talk about health, so I'm giving you the areas which are priority areas for any country, including our own country. Energy, savings, your sensing and harvesting energy production, health, which is implants and rehabilitation, and water resources. Textile has a big role in all these. Now I come to the topic. So this is something which I wanted to instill in your young minds, that it is an area where you can actually spend your lifetime doing things which have not been done. And nanotechnology is one such tool to help you realize some of these properties. So I'm now going to discuss some of the applications and what nanotechnology is and how it can be applied to textiles. Now I'm going to give you terms which you say we know it, why are you wasting your time? But I'm trying to just tell you what I know, okay? What is nano? We all know this. Something which is 10 to the minus 9 meters. Less than 100 nanometers, we say it's nano. But really, if we go below 10 nanometer, then it becomes nano. And it has properties which we want them to have. And I'll talk about how. And for those who are not aware of nano, yes, you take your fiber, your hair, and you divide it 1,000 times and you'll get something nano. So you must have seen this picture on the net. This is taken from the net, not my picture. So it is far smaller than what we have seen in the past decades. So size is smaller, so it has large surface area. I mean, we all hear about it. So what is so special about it? How does it make too much of a difference? Just the area is different. Think about it. Nanoparticle means cluster of few atoms. Not large amount of atoms, not Avogadro's number. When we talk about bulk material, we'll talk about 10 raised to the power 23 atoms or molecules. Not that. We are talking about 10, 20, 30, 40 atoms. That makes the nano. A cluster like this, that is a nanoparticle. So, what is big deal about it? That gives us a unique property. I'll tell you why. The surface atoms, that is what gives us, those atoms which are on the surface of your particle, they are unsatisfied. Why are they unsatisfied? An atom in the center of a bulk material is surrounded by its own family members. A gold atom surrounded by gold, satisfied. When we are in our family, we are very comfortable. We put you out of your family. You are not so comfortable. You go to the outside world. The atoms which are on the surface, they have company on one end to the bulk, but they don't have any company on the surface on the other end. There is air. What is there? Something they don't like, they don't want. Their bonds are dangling. Their bonds are dangling. They don't have anything to satisfy, so they are highly unsatisfied materials on the surface, and that makes them highly reactive. They want to find someone of their own liking. They want to join with something. And that is what is important for us when it goes to nano. Now let's look at how these clusters are formed, okay? Some simple examples like zinc oxide and titanium oxide, you all have learned in your courses and done work on it. This is some very simple chemistry I'm showing you, don't get bothered with it. What I want to show you is, say titanium oxide is formed, for example, by a TEOS, right? Titanium hydroxide of various kinds, right? Now this condense to remove water and form a TiO2 bond. This will continue to happen in all three directions and TiO2 will be formed or ZNO will be formed. So if you look at that, the particles starting to get formed in between, but on the surface, the same groups are still there which the precursor had. So a ZNO particle is not just ZNO, a gold particle is not just gold, it has a lot of surface chemistry on the surface because it got formed from a precursor and all the precursor did not get utilized because the surface did not have anything else to react with. So what you get in the lower anatase TiO2, a lot of groups which are OH groups around it, which is naturally its own part. Now this is a chemistry, right? You can do surface modification. This gives you an anchor to do something with the nano. Then comes a question is, what nano, what size? I said less than 10 nanometer. So there's something called degree of dispersion in nano. What does it mean? It says the ratio of surface atoms to total atoms in that particle. So this is your particle. So there are atoms which are inside that cluster and there are atoms on the surface which are unsatisfied, as I told you. The smaller you make the particle, the bulk will become smaller. So satisfied atoms will go down while unsatisfied atoms will increase per unit weight or volume of the material. So this diagram. So what happens that your bulk, as you go for a larger, as you go to the larger particle diameter, most of the atoms are bulk atoms, very few are surface atoms, but as you go down in the particle size to say 1 or 2 nanometers, the whole thing changes. Almost 80 to 90% of the material is surface. There's hardly any bulk in it. And if you look at the surface area of these unsatisfied, that goes like meters square per gram, almost 500 meters square. Please imagine what is 500 meters square, almost 5,500 square feet of area, right? For 1 gram of material. That is the kind of area it creates. It's not just the area, it is the area which is highly reactive. It is the area which has a lot of other kind of groups where you can do chemistry. So this gives you properties of nano. We all know high surface area to volume ratio, but what this surface area means I just told you. Where you can do a lot of unique chemistry. More unstable atoms, so highly reactive. This, because suddenly there is a surface and bulk is very small, the electronic levels created in these particles are very different from the bulk. So all the optoelectronic properties change. And since the surface is very, very high, and you can do a lot of chemistry and a lot of work with the surface, and surface is what participates in an atom, small amount of nano will do wonders. Where bulk you would have to put 5 grams, nano you will have to put 0.0001 gram. That is the kind of difference it can make when we talk about commercialization, applications of nano. So what you can do, you can start with modification of the nanoparticles itself. Very simple example, a simple ZNO particle will have OH groups, but you can combine them with all kinds of molecules to create whatever surface molecules you want. So when we say nanoparticle, we cannot apply on textile, it will get washed off, and all those kind of challenges. These are our anchoring groups. These are our ways to actually put them to textile or any other surface which we want to modify. other ways of doing that. You can graft onto these groups. You can add them later on, generate them within a grafted material, a polymeric system or a template, and create different kinds of applications from this. But there are challenges. Challenges are if the surface is reactive, it is highly unstable. So stability is a problem. You can't just make powder of nano material and send, it will never remain nano. You put water and stabilize it in a solvent or water, then you have something to transport which has no value to the industry, which will have to be thrown out. Upscaling is an issue because the productivity is low. You can't make kgs and tons of nanomaterial. You can make only grams and hundreds of grams at the most. Processes are different. You may have to do ultrasonication, high speeds, homogenizations and things like that, which are industrially less relevant processes. And then we talk about textile, it says cost is going up and the durability is poor, and how do we worry about it? What do we do about it? But then there are advantages also. It will give you unique properties which no other material, no other finish will give you. You have to use them very small quantities. So even if the cost is high, your eventual application cost may come out to be lower. And one nanomaterial can give you multiple functionalities. Now, some of the nano initiatives I've talked about. Nanofibers through electrospinning, you all know that. I'm not going to talk about nanofibers today. Nano surface modifications by processes like plasma. You can do right on the surface some chemistry. Again, I'm not going to talk about that today. Nano finishes by actually applying particles or making particles right on the surface of the textile is what I'm going to talk today. And nano composite fibers, where in fibers you are putting some nanomaterial. So we are going to talk about nano finishes, some examples. Again, this is a list of materials and properties which you must have heard and read. We can make textiles antimicrobial, antifungal, antibacterial, antiviral, self-cleaning, moisture managing, very important aspect for sports industry. Pollutant and odor absorbing, again, a very important area of concern today. Anti-reflecting, flame retarding, and so on. Now I'll give you some examples of how nano can transform some of these materials and what kind of approaches can be used. So protective textiles is something where we don't want either the microbe should not stay on the fabric, it should detach itself, or it should get killed, things like that. So various ways of defending. And we know these materials. They are quaternary ammonium salts, halamines, silver nanoparticles, graphene oxides, triclosans, betaine. All these are the materials which you can use for antimicrobial, that is antibacterial, antiviral and antifungal. Nanosilver, let's talk about that. Very, very popular material. We all know it is an antibacterial agent, very strong, but commercially unviable. It has been commercially unviable. Why? Because as soon as you make silver nano, it becomes brown in color. And that cannot be put on a shirt or a dress. It will not give a good appearance. We all know that, right? Poor aesthetics. Cost is high because you have to have concentrations of 50 to 100 ppm. Only then it will, MBC means minimum bactericidal concentration, which is required to kill bacteria. I told about instability during storage and unstable during application. And as soon as you put a fabric into a dispersion of nanosilver settles down. It doesn't remain in dispersion so easy. So what can you do? Well, solution is, again, nano. I just told you about nano. Nano is surface, right? All about surface. We need to think about changing both the shape and the size. And I told you, size matters a lot in nano, right? So this is one of the experimental results I am sharing with you, where the reducing agent, silver nitrate reduced using reducing agent, and a particle size. See the function. Depending on how much reducing agent you add, the particle can become non-blue, that is yellow and brown, or blue in color. Now, blue is something textile people like, isn't it? We put all kinds of brighteners and non-yellowing agents which are blue in color to enhance that. So, if you look at this regime, by tuning the right amount, we can actually go to a particle size which is about 3.5 nanometer. So, I am not talking about 20, 30, 40 nanometers. That's not nano. I am talking about 2, 3, 4 nanometers. You change temperature. Just changing the temperature by few degrees at which you are doing the reduction, it will bring the particle from 12 or 10 to 2.1 nanometer. Nothing else has been changed. Not only that, the shape has been different in these temperature regions. Something between 40 and 68 or 70 is blue region, and all other are non-blue region. So, you can actually learn to change the nano the way you want, not only the surface groups, but also the size and the shape. When we talk shape, blue regions means a triangular shape. Yellow and brown regions means a spherical shape. So, you need to change that because the optics have to change to give you what you want. So, this is an example of a blue color, silver. You will not see a particle in this because you can't see 2 nanometers. Okay, it will be like your dye solution. But it is actually particles, it's a suspension. It's not a solution, it's a suspension. But it will not now settle down. Why? It has become so small, and then on the surface of those particles, since they were very reactive, we have added a group to stabilize them, a chemistry. So it becomes highly stable, so stable that for 2 years it doesn't get settled down. And that makes it highly reactive towards microbes, so and so that MBC values from 50 to 100, it comes down to 0.05 ppm. So 1 by 100. So your cost of application goes down few paisa from few rupees. Okay. Another example, zinc pyrithium is a very good anti-fungal agent. We all know that. But it's not, it's used in various kinds of products in the market. Easy to synthesize also. But it has problems. It's insoluble in nature. You can only have bigger particles. Dispersions are unstable. In sunlight, it does not remain active. So, how do you apply it to the textile? Again, you have to think about modification. You can take viscose or cotton, you can phosphorylate it. So, you have created some groups on the textile, and then you actually make the nanoparticle right onto the textile by putting zinc precursor and ligand solution. So, this phosphorus group, it captures these reactive agents and create this nanoparticle right onto the textile surface, which is anchored. So what happens is something like this. I will not bore you with the chemistry, but cellulose, you can simply put a zinc pyrithium compound, or you can phosphorylate it and really anchor it very well. And it can be shown that it is actually making those anchoring by solid state NMR studies, that we can see the phosphate group getting formed when we have phosphorylated textiles. So shift confirms the association of zinc with cellulose phosphate. And we can see all kinds of groups even after application. And you look at how does it work. This OD is optical density. If you are trying to grow the bacteria, so more bacteria goes, OD will be high. No bacteria grows, OD will be 0. So for a blank solution where there is no bacteria, it is 0. but for certain combinations of material which we can create, the ODs are again very close to zero, just 1 or 2%. So that means you have inhibited the growth of bacteria. 10 wash, it remains so. 20 wash, it remains so. But some combination will go up and some combination will remain stable. The idea here is not to tell you what combination, and these are all published works, right? You can go into the literature if you want. The idea here is to tune your material in such a manner that you are able to capture the properties of nano right onto the textile where you want it, so that it works in very small quantities and very effectively. And the concentration which we use here is so small that does not affect the color or appearance of textile in any significant manner. Then, how about the antifungal properties? Yes, there also it is working. After 0 wash, obviously as prepared, and even after 20 wash, 94 to 96% is the effectiveness. Very high activity. There is nothing called antifungal textile which is wash proof like this, right, in industry today. And I told you, nanomaterials gives you multifunctionalities. Since there are metal, since there is zinc in it, and some other compounds, we can have silver if we want as a Pyrithian metal, or a selenium or magnesium or copper or zinc. You can actually have different properties. So UPF is a protection factor, right? Ultraviolet protection factor. And some of the materials give exceedingly high protection. Again, till 20 watt. So some of them extremely high, but all of them are fairly high. Okay? So multifunctionality, while the material being put is very, very small. Very, very small in quantity. This is antibacterial, antiviral, etc. Now I come to moisture management. Very, very important industry for textiles. Why? All the sport industry is based on this, right? And most of it is made from polyester. We know polyester wicks, so polyester is put and then it has to evaporate, right? All those things. But there are problems. What are the problems? Polyester is cheap, highly wicking, we can make it microfiber, etc. But it is hydrophobic surface, so though it has channels but doesn't wick till you make the surface little hydrophilic. Otherwise, the wicking will not be there. And all these kinds of problems, because being a synthetic fiber, it creates all kinds of irritations. So it's uncomfortable to wear. What is important is that sweat should not only be removed quickly, it should also get evaporated quickly. So if you look at the three phenomena which are important for a sports industry, is it should be able to absorb the moisture from the skin, wick it to the outer layer, and then evaporate it also. So cotton is not able to do the evaporation, right? That's why we don't use cotton or viscose or something like that. It holds the water. Polyester does the evaporation to some degree, but the problem is wicking and absorption. It doesn't do that. For wicking also you need microfiber, but then treat it with some hydrophilic agent, and polyester is such a inert material that whatever finish you put on a polyester fabric, in few washes it goes away, right? So your textile is not that durable. So what can you do? Again, create some nano formulations. What these nano formulations will do? So this is untreated PET. This is a PET treated with commercial finish, which is used in industry. And this is along with a nanoparticle. Now you will see such a high density of nanoparticles, but amount added is 0.5%. Why? Because the particles are very small. They can actually cover the surface very, very easily with very small amounts. And what happens to the wicking? This is untreated, no spreading. You put a moisture, a commercial moisturizing finish, it wicks to some degree because that is what is required. It's all microfiber polyester. But you put a nanoparticle resin finish, and see the wicking going drastically up. So if you look at what is happening, so this is an experimental setup prepared where there is a base glass plate simulating the skin with a temperature of 37, a fabric of polyester, and some water is added. So in the center there is water, which you can't see in picture very clearly, but so that's why it has been marked. And we are trying to see from a thermal camera what happens to this. So in an untreated polyester, you can see the water is there at the center and remains in, if after 10 minutes also there is not much change. It's not able to evaporate at that temperature. You put a commercial finish, a hydrophilic finish on polyester, micropolyester, this starts to evaporate and you can see it is becoming a little green. But still it is there. And you put a nanoparticle plus resin finish, it disappears in 10 minutes, water. It's just not there. It has evaporated. It's the magic, isn't it? What a nanoparticle is doing, it's still the resin is there, the same resin, the commercial resin is still there. Just what we have done is added a little amount of nanoparticles. If we look at how with respect to commercial finish, it is changing. This is unwashed sample, this is after washing. So commercial finish from 90% absorption rate, it goes to 40. Vertical wicking from 700 goes to 400, evaporation from 150 to 55. So with washing, it drops. But if you put a nanoparticle, it not only binds better, but see the rates of evaporation, wicking, evaporation, many times, 300% more. And all three properties, absorption, wicking and evaporation, which are needed, are going up. So what is a possible mechanism one can explain? In a normal fiber, since there is nothing to like water, it doesn't get absorbed so easily from the skin. If you put a finish, which is commercial finish, it has some hydrophilic groups, allows the moisture to wick. But in a nanoparticle finish, if you see a cartoon here, there is a particle with lot of OH groups. Remember, I told you if you make a zinc oxide particle, it has lot of OH groups around it. Why? Because that is what is coming from zinc hydroxide, which made the particle in the first place. So this particle has certain OH groups, so it gives you higher hydrophilicity, but these do not bind the moisture so effectively, so it evaporates also very easily. It's like wool, right? Wool captures a lot of moisture, but is also easy to evaporate. That is why in UK, sports garments have wool in it, because it's easy to evaporate. It's a very, very comfortable material. Okay. But here we can do that trick by small amount of nanoparticle. So this is commercial finish and this is a nanoparticle finish. So nanoparticles again have low binding energy with water. So it captures when there is a water, but evaporates when there is an atmosphere for evaporation very easily. Let's touch another area of concern, especially in Delhi. Mumbai is far better. You have sea to take care of you. We don't have an ocean around us. Pollutant and anti-odor, right? Some people are very concerned about the body odor also. Again, another class of materials you must have heard about is metal organic frameworks. Physicists love this material, but we are the people who can use it. They only study, we use. If we can integrate a material like this, which is highly, highly porous, to a textile, we can create wonderful material out of it. So that is what has been done. ZIF-8 is one kind of a MOF. ZIF-67 is another kind of MOF, and there are whole families of MOF which are there, which you can integrate. Again, what is the chemistry? You have to create something on the textile so that this MOF is actually formed right onto the fabric. Alternately, you can apply MOF particles also with a finish. That is also possible. But you can actually do an integration, chemical integration. And applications can be filter media, indoor air filtration like upholsteries, filter gaseous pollutants, etc. And what happens is, this is a textile with grown MOF under a micrograph. You see a lot of it here, but actually it is not. It is under a very high magnification. Okay, that you see these kind of things deposited. Really speaking, the addition is less than 1%, 2%, not more than that. And it actually absorbs. This is a colored MOF which has been formed, ZIF 67. And what happens, you put it in some kind of a pollutant air, which is in a jar, and changes color by absorbing. And shows you that the fabric is actually absorbing the pollutant. What kind of pollutant? Benzenes, aromatic compounds, all kinds, anilines. So this has been tried, where model compounds like aniline, benzene, and styrenes have been used to absorb, and you can see the absorption at milligram per gram of the fabric, not of the finish. Very active, very, very interesting kind of thing. And what you have added is nothing much. Another work which is important, a nanomaterial called Janus particles. What is Janus particles? Two-faced, which have two different faces, like Janus god. Okay? Where you can have half of the material covered with one and the other half of other. And this gives you a beautiful electronic properties, wonderful electronic properties. You all know TiO2 is a self-cleaning, right? Material, photocatalytic action. So if you take a controlled dye and expose it to UV light, it doesn't decolorize. So these dyes which have been taken are UV stable dyes. You put a Janus particle which has been prepared, suddenly there is a lot of decoloration. This is in dark, that means they are absorbing the dye on the particle, and that is with UV, that it is also disintegrating it along with time. P25 is a very natural material commercially available. You compare it with P25, Janus compares very well with a dark thing, but if you go by UV light, it has much higher activity than simply the P25 which is there in the market. So if you just compare various kinds of structures created in the literature, this Janus particles gives you almost 211 times the core shell particles, 28 times the P25 particles, and 60 times the Janus particles created by other methods. What has happened? What has happened is that the electronic structure has changed completely. Other kinds of particles give you a two-dimensional, 2-degree exponential decay of charges, because charges have to excite and decay with time to give you this activity. And this one gives you a third exponential decay, which if you convert to an electronic diagram, gives you absolutely a new kind of material with electronics. And what you have done is just associated two different materials together, that's all, in a specific configuration. My idea here is not to teach you how to do it. My idea is to tell you that what is possible to do and what else can be done. You put these particles, Janus particles, on say cotton fabric, a much faster decay. Or you just put it on a fabric and look at the near IR reflection. The reflections are higher with P25. With simple Ti2 macro particle will be still higher, and with SiO2 may be still higher, but with Janus it is the highest among these. What does it mean? All the heat is transmitted through IR, right? From the sun. If you are reflecting with this fabric, That means now the heat is getting transmitted less to the other side. So you do a small experiment, you take a box, you put your fabric here, put an IR lamp and see how the temperature inside rises with time, right? And what we see is with Janus particles, the temperature rise is much smaller. And what is the concentration being added? 1 to 2%. 1 to 2% is nothing. When we talk about finishing 4, 5%, 10%, 15%, we add karte hain log, right? We are not adding much. While we are adding other particles of similar nature, they are not working that well. They are working, but this is working much better. Just a nanostructure created in a different fashion. So this is bringing me to the close of my talk today. Other areas, some other opportunity I get, I'll definitely discuss. What are the areas? Nanodiamonds. Diamonds is the choice of jewelry, right? But nanodiamonds are now the talk of the world, and you can put them and generate them on your fabric. Okay? So, and wonderful properties you can get. Nanofibers, which I have not touched, and e-textiles, electronic textiles, is something which we all have to look forward to. So whether we can make supercapacitors, sensors, piezoelectric devices, I mean there's a whole list of materials which can be made right from pure textile materials. So this is the conclusion of my talk, that textile materials are important engineering materials. That is first thing which I said. You must be proud of using textile materials. And there's no alternative to that. And it has potential to create new functionalities and novel applications. So I would like to acknowledge my team. Professor Manjeet Jassal has been co-investigator in many of these studies, and the students, very important part, and the funding agencies. Thank you very much.
Thank you, sir. It surely felt like a masterclass, which have given enough pondering thoughts to us about what all can be done with the nanotechnology. And I would now request a few questions, if there are any, from the session to sir, directed to sir.
Very interesting. Really an amazing array of possibilities you have presented. I was just, wondering about one aspect. When we use silver and zinc and TI, where particularly human contact will be possible, there have been known to be some biological side effects. So I would like your opinion, how to take care of them.
Yeah, so this has been a very major concern in nanotechnology, and the world is divided on it today. So people don't know what to do, countries don't know what to do. So some countries have outrightly banned for now, right? And some countries are saying, you show us and we'll consider. So for example, US has not banned nano, but they're not allowing anything also. They say, you prove it, we allow it, right? So we are in a domain where people don't know, because as far as silver is concerned, it has been shown and proven by many studies that you can consume silver in large quantities and nothing will happen to your body, except your body will become a little blue, because probably form all nanoparticles, blue nanoparticles inside. So, but small quantities will not harm you at all. There is a concern of fish life, water life, aquatic life. But that is true with any antibacterial agent. So as a society, many of them are non-destructible. You put it, something will get eaten by some bacteria or something. They may get disintegrated, they may not get disintegrated. There is a question of whether and how much one should use. But the important thing is, science and technology always tend to harm the environment. How much harm you will tolerate is a question which every industry has to answer. If you want natural environment, actually the industry and the economy cannot grow. Simple as that, right? So when someone asks me in a class of waste management, I say the only way of managing waste is that don't produce. Because if you produce, it will go to waste one day, right? There is no way that you can extend the life, but that's it. Eventually it is going to go into the waste. But we want countries to earn more money, consumptions to go up. So we are actually anti-environment from the economic policy point of view. So this is a debate. Now the question is how to make it safer. That is the solution. It should not leach out as much. Okay? So the idea is your technology should be responsible enough so that it does not harm the human body if you wear it. So for example, the blue silver I was talking about, extensive studies, animal studies have been done to see whether they harm the animals and the skins and other thing, and has shown to be very, very safe because the quantities which you are using are extremely small. So with nano, the trick is you have to go small and little as possible so that it doesn't affect your body. And obviously you must look at the implication even of that small quantity, and that is true with any technology, not just nanotechnology. It is true with mobile phones and everything. We have to study the effect and long-term effect of these technologies. And if they are harmful, we must not use them. But not all of them. Zinc oxide, very safe material as of now. TiO2, zinc oxide, some of the materials are quite safe. But how much safe, what is the long-term effect, these are the things which one has to study. So yes, there are precautions one has to take and being responsible in using them. You are right.
I have one question, please. I mean, the quantum effects of, or the quantum influence on the quantum properties because of the size, nano size are known. In your studies or elsewhere, have you seen the effect on mechanical properties as a result of coating with nanoparticles? I have a second question, but I'll see if there are other questions.
So whether we have seen the mechanical properties getting affected. So in nanofibers, yes. Because there we can actually measure.
Not as a coating or...
on the textile material where it is added, absolutely no effect at the concentrations, not at all.
But if you wanted to have something, can you...
What we have seen at times is it improves the mechanical properties of fabric because the frictional properties of the fabric changes. Inter-yarn friction changes. So it gives you a better tear and a better tensile strength, 5-10%, not much.
Okay.
But it doesn't deteriorate.
Okay.
Yeah.
Thank you.
On the moisture management technique that you have talked of, is there any effect on the dye property, that is the fastness, especially the sublimation of the dyed fabric? If it's a black fabric and you apply this, and during when the moisture moves out, is there any effect on the sublimation property of the dyed material?
So we have tried dyeing these materials after application of the finish, we have done it two ways. Dyed the material, then finished it, and finished the material, then dyed it. And both ways, it is fine. One of the changes at times we have seen with some nano finishes is that your water absorption changes. See, you can make it hydrophilic also, and it can make it hydrophobic also. It depends on what structure you are creating. So it sometimes makes it a little hydrophobic, but then it's the initial few seconds which are required for it to start absorbing. Thermosol properties have not been affected because it is quite porous. All these materials are highly porous. Between the particles, it sublimes very easily. Fastness of dyes for thermosol we have not checked. We don't know the answer for that. But I doubt there would be any change because it is a surface phenomena which we are doing. We are not really disturbing the bulk of the material in any level. So I don't see or anticipate any change in the bulk performance of the material. So dye eventually goes into the solid bulk, although it is on the surface, but inside the bulk of the surface, not right at the surface layer. This we are talking about nanometers. The changes in the 100 nanometers are less, very small.
No, the wet rub may change. There is a possibility of wet rub being deteriorating on the surface.
I didn't get your word.
The wet rub fastness properties, the wet rub may get affected. Means the possibility, because I do not know about this, but I'm just trying to think aloud.
Chances are, one has to study, but chances are it should remain all right. But yes, if the dye goes and deposits on the particle, and then it would be affected, yes.
Thank you, sir, for accepting our invitation to the 8th late Professor W.B. Achwal Endowment Oration for the year 2024. We are thankful to you for sharing your expertise and knowledge with the audience. Your presence was a privilege for all of us, and I can surely say on the behalf of this august gathering that it was an enriching experience for everyone to listen to you. Thank you again for making it memorable. I now invite Professor R.V. Adiverekar, Dr. Deepti Devbakar, and Mr. Abhijit Achwal to hand over the memento as a token of appreciation to our speaker, Professor Ashwini K. Agrawal. Please, sir and ma'am. Thank you, sir and ma'am. I would now request Dr. Saptashi Maiti to deliver vote of thanks.
Respected dignitaries and eminent personalities present in the auditorium, my colleagues, students and friends who are present here, I thank you all for joining us in today's evening program, Professor W.B. Achwal Endowment. First of all, I sincerely thank Professor Achwal's family members, especially his children, Mr. Abhijit Achwal, Professor Deepti Devbakar, Professor Dilip Devbakar, and his other family members, and needless to mention Dr. Habbu sir for their continuous support and active participation to organize this program annually. We are very happy to have them with us on such an auspicious evening. The program would not have been initiated without their active cooperation and enthusiasm. I take the opportunity to thank the speaker of today's event, Professor Ashwini Agrawal, delivering an excellent talk on smart textiles through nano-modification. He has clearly and lucidly explained the significance of nanotechnology and its role in transforming textile, which is usually understood as a dress material, but it can be used in such a next generation material for future textiles. And thank you, sir, for your such a fabulous talk and your expertise. I am grateful to our acting Vice Chancellor, Professor R.V. Adivarkar, he is the Dean HR of our institute, for his gracious presence in today. I would also like to thank our registrar, Professor Jogi, though he is not there, but his support is always there to organize any event in our institute. And finally, I take this opportunity to thank our head, Professor Ravindra Kale, the head of the department of our textile department, for his constant enthusiasm and tireless effort and guidance to his colleagues and students to organize any event. And last but not the least, I honestly thank all the audience for their positive and enthusiastic presence. The students from Sasmira and I guess SNDT and Nirmala Niketan is probably also there, like every time. So thank you all. Thank you. Stay safe and blessed.
Thank you, sir. I would now request everyone to please rise for national song. Now, I request the dignitaries and the family members of Professor Achwal to gather at the dais for a group photograph. And students are requested to please be seated. And I now request for all you to proceed for high tea arranged outside.